in generalized linear models with examples in R. That book right there. And we are on, we're in chapter 3, question 314. Okay. So, so this has a lot of parts here. And we're talking about a data set called Manuka right here. And so we're asked to do some things, build a model and so forth. And so we'll just look at that as we come to it. And then we're given the information that that the authors who put together this data set and then presumably wrote a paper on it and had it published later retracted that because they said that that their results were strongly influenced by a high outlying value. So when the results for that patient are omitted, the association is no longer statistically significant. Okay. So they retracted the paper, and then we're asked to do some stuff with the data, again, omitting the offending observation, and then compare the two results. Okay. So the first thing that we'll do here is to install and load the GLM's data package and load the correct data set here, Manuka. Okay. And so the first few rows of that data set look like this. All right. Well, so there it is. And so the first thing that we're asked to do is to plot the percentage reduction in wound size over 2 weeks against the initial pH. Okay, so first we have to create the percentage of reduction in wound size here with so I'm creating this variable and attaching it to our data set, and so I'm just taking size 2, which is the size of the wound at 2 weeks, versus the initial size, right? So that's the difference, and then divided by the initial size, right? So that will give us a percentage of change. And then I'm just plotting that, okay? That's all we're asked to do here. Okay, so I plot it, and it looks like this. Great. All right. So now we're supposed to fit the corresponding regression equation and draw the regression line. Okay, well, we need the regression. And so here, I'm just using this as my model. Size change, the variable that we just put in there, being regressed on the initial pH. Okay, and so let's plot this. So I print out the summary, and we'll come back to the summary later, and it looks like this. Okay, so here we have the mean line. So I've just plotted, I've just recreated that same plot, and then if you just put in AB line, and then use the model, you get you very easily get this black line here, which is representing the expected value, the expected regression line for the model and the data. Okay, and then I've also just gone ahead and plotted confidence intervals for the mean as well as the whole spread of the data, so incorporating not only the standard error of the mean, but also the full standard deviation of all of the data. So you have kind of these enveloping, confidence intervals. Okay. Okay. So this is what we get. Okay. And in the next question, we're asked to interpret, to write down the regression model and interpret the model. Okay. So I mean, I don't know that we need to write down the model. I mean, the model is, can just be read off of the code, and so that's basically what I've put here. Okay. And so what is the major finding? Well, I guess the major finding is more or less that wound size or change in wound size tends to change with pH, right? So with the initial pH, right? So a higher initial pH causes increased wound size 2 weeks after the initial insult, and so this also translates to values below about 7.9 initial pH tend to, or expected to, on average, lead to healing within 2 weeks, or I guess smaller wound size, and after that lead to larger wound size. Okay, on average. Again, not in all cases, but on average. Okay, so now we're supposed to perform a diagnostic analysis for the model and find the offending observation. And so for this, I just started by plotting the model, okay? And where we can identify this outlier is right here, this guy right here. Maybe I'll zoom in a little bit here. Okay, it's this observation 19. Okay, so so what we're going to do is we're going to remove observation 19 from the data set, and then repeat basically what we've done and compare the two models, the model with the full data and the model with observation 19 removed. Okay, so that's what I've done here. It's basically the same thing, but notice that I've created a new data set here where I've removed observation 19. Okay, and so we go through all the same things, and then I plot both of these. Well, actually, before we get to that, I also ran the same diagnostic analysis for this modified model, and we can just take a quick look at it. Anyway, so here that is. It does seem to fit better, right? There's no more outlying observations. It seems to fit the QQ line a little bit better, so it probably does fit a little bit better. So anyway, but let's look at the plotted results here. Okay. So you can definitely see that there is a difference in the two plots and the two models, but the general findings are really quite similar, right? There still seems to be this positive association between the two, and kind of the break point between healing and not healing, or getting smaller and not smaller, seems to be pushed up a little bit, but the general idea seems to be, pretty similar. Now, the authors apparently stated that the results were no longer significant, and so I just actually let me make sure that we can print that. And let me. Sorry for making you watch me do this. Run this one more time. Okay. So just a couple of things. So I had mentioned that kind of this threshold for healing, I guess, is roughly what I called it. It was previously like 7. What did we say here? 7.9, and here it's kind of pushed to the right, and it's a value of about 8.1. If you're curious about how I calculated that, so what I'm looking for the pH value where there's no change in size, or at least expected to be no change in size, and so the way that I did that was with this formula right here. So you can kind of back engineer that if you want, but it's not really relevant to the question. So anyway, so it shows that, so the author said that the results are no longer significant when we remove that outlying value, but we've seen these plots where they're very, the findings are directionally very similar. Now, when you go up here, you do realize that that according to a 0.05 significance level, that it is true that it is no longer significant, but we're really talking about, minor differences. It's not like the entire story changed, and so it seems like the redaction was probably a little bit ill-advised, I would guess. But anyway, so just some final thoughts here. So the findings are very similar, although again, in the second model, the findings are no longer quote-unquote significant to some arbitrary level. You can tell I'm not a big fan of their mode of reasoning here. But I don't know that this necessitates that they retract the study. But it may have been the case that these authors, being subject matter experts, had a more complicated regression model here that is being hidden from us. Yeah, so it could be that with a more detailed model that possibly more accurately captures the relationship between size of change and pH, it could be that the difference between the two models in that case would be much more noticeable. So anyway, we will call that good.